Hello everyone, welcome to Enthusiast Learning. Hope all of you are fine.
Today we will do thermodynamics. This video is beneficial for class 11, JEE, NEET and KVPY. So let's start. Thermal equilibrium. When all macroscopic properties like pressure, volume, temperature, mass, number of moles are constant and do not change with time. A body is said to be in thermal equilibrium with its surroundings if it is insulated completely. Zeroth law of thermodynamics. When a body A is in thermal equilibrium with another body B and also separately in thermal equilibrium with body C, then body B and C will also be in thermal equilibrium with each other. This statement defines the zeroth law of thermodynamics. This law is based on temperature measurement. Internal energy U. The total energy possessed by any system due to molecular motion and molecular configuration. It is called internal energy. Internal energy of a thermodynamic system depends on temperature. It is characteristic property of the state of the system. Work in thermodynamics. Work is equals to power into delta V, or work can be also integral P dV. Here P is the pressure, delta V is change in volume. And work done is also equals to area under the PV graph. If work done by a gas is positive in expansion and work done by a gas is negative in compression. PV diagram. A graph representing the variation of pressure with variation of volume is called PV diagram. The work done by the thermodynamic system is equal to the area under PV diagram. Here it is shown. Now the first law of thermodynamics. The heat transfer into system is responsible for change in internal energy of a gas and work done by the gas. That is, delta Q is equal to delta U plus delta W. Delta Q. Heat supplied to the system will be positive. Heat drawn from the system would be negative. Now delta U. If temperature increases, delta U will be positive, and if temperature decreases, delta U will be negative. Now thermodynamic processes. A thermodynamical process is said to take place when some changes occur in the state of a thermodynamic system, that is, the thermodynamic parameters of the system change with time. First, we'll talk about isothermal process. A process taking place in a thermodynamic system at constant temperature is called isothermal process. Isothermal processes are very slow processes. These processes follow Boyle's law according to which PV is constant from du is equals to NCV delta T as dt is equals to 0, so du will be 0, that is internal energy is constant. From first law of thermodynamics, dq is equals to dw, i.e. heat is given to the system is equal to the work done by the surroundings. Work done W is equal to 2.3026 mu RT log 10 volume final upon volume initial, which is equals to 2.3026 mu RT log 10 pressure initial upon pressure final, where mu is the number of moles, R is equals to gas constant, T is absolute temperature, and volume initial volume final and pressure initial pressure final are initial volumes and pressures respectively. After differentiating PV is equals to constant, we have bulk modulus of gas is an isothermal process. PV curve for this is rectangular hyperbola. Now adiabatic processes. A process taking place in a thermodynamic system for which there is no exchange of heat between system and its surroundings. Adiabatic processes are very fast processes. These processes follow Poisson's law, according to which PV raised to power gamma is equals to TV raised to power gamma minus 1, which is equals to T raised to power gamma upon P raised to power gamma minus 1, which is equals to constant. from dq is equals to Nc delta T. C in adiabatic process is 0. So dq will be 0. That is molar heat capacity for an adiabatic process is 0. From first law, du is equals to minus dw, i.e. the work done by a system is equals to decrease in the internal energy. When a system expands adiabatically, the work done is positive and hence internal energy decreases. That is, the system cools down and the vice versa. Work done in an adiabatic process is W is equals to N R delta T upon gamma minus 1 is equals to P initial V initial upon gamma minus 1 minus P final V final, where T initial and T final are the initial and the final temperatures. Now, isobaric process. A process taking place in thermodynamic system at constant pressure is called isobaric process. Molar heat capacity of process is Cp and dW is equals to Ncp delta T. Internal energy du is equals to Ncv delta T. Process equation is V by T is equals to constant. PV curve is a straight line parallel to the volume axis. Isochoric process. A process taking in a thermodynamic system at constant volume is called isochoric process. dQ is equals to Ncv delta T. Molar heat capacity for isochoric process is Cv. Volume is constant, so dW is equals to 0. Process equation is P by T is equals to constant. PV curve is a straight line parallel to the pressure axis. Now, cyclic process. When a thermodynamic system returns to initial state after passing through the several states, then it is called the cyclic process. Here it is shown. Isothermal processes and adiabatic processes. Isothermal process is a process that takes place at constant temperature is called an isothermal process. Equation of state for isothermal process is PV is equals to constant. Work done during an isothermal process is RT log Vt upon V1 is equal to 2.30 RT log E P2 upon V1. We have done this earlier also. Adiabatic process, a thermodynamic process that takes place in such a manner that no heat enters or leaves the system is called adiabatic process. Equation of state for adiabatic processes PV raised to power gamma is constant and TV raised to power gamma minus 1 is constant. So P raised to power gamma minus 1 upon T raised to power gamma is equal to constant. Work done during adiabatic processes is R T1 minus T2 upon gamma minus 1. Isothermal and adiabatic curves. The, the graph between the pressure P and the volume V of the given mass of a gas for an isothermal process is called isothermal curve, and for adiabatic process it is called an adiabatic curve. Here you can see the slope of the adiabatic curve is equals to gamma times the slope of the isothermal curve. Very, very important. Second law of thermodynamics. The second law of thermodynamics gives a fundamental limitation to the efficiency of heat engine and the coefficient of performance of refrigerator. It says that the efficiency of heat engine can never be unity or 100%. This implies that the heat released to the cold reservoir can never be made zero. Kelvin statement. It is impossible to obtain a continuous supply of work from a body by cooling it into a temperature below the coldest of its surroundings. Clause's statement. It is impossible to transfer heat from a lower temperature body to a higher temperature body without use of an external agency. Reversible process. It is a process in which the system can be retraced to its original state by reversing the conditions. Irreversible process. It is a process in which the system cannot be retraced to its original state by reversing the conditions. Here it is shown. That is it for thermodynamics.
Thank you for watching. Please subscribe the channel and like the video.